Okay, with a little more enthusiasm. Hi, Zion.
Is he on FaceTime?
Leah!
He's on FaceTime?
No.
No,
he asked me to record this. Look, it's on the screen.
I thought he was tuned in from Miami.
No.
Is he still in Miami?
We're just going over the
review packet. Alright, number one. You're asked to find Trapezoid Rule, n equals 4. Sorry.
No, he's at a golf.
What's wrong with it?
Oh, really?
Yeah.
I thought he
was in Miami.
Oh, he's back from Miami.
Yeah.
Alright, n equals 4. 1, 2, 3, 4. So n equals 4 is tailor made for this tape. Alright, Trapezoid Rule.
Is it cool if I take a picture of that?
Of what?
Like, whatever you finish.
Yes.
Alright. Because I like to do the worksheet while looking at the answers.
Alright, so Trapezoid Rule. So that's going to be 1/2. The height is going to be the distance between the x values, so that's 3. And then sum of the two subintervals. So 4 plus 5. That's the first trapezoid. The second trapezoid has the same 1/2 and the 3 because it's uniform width. So 5 plus -5. Very good.
This is 0, right?
Negative. And then last one. Alright, there. Go ahead and calculate that. You are expected to calculate this when you take the test. What's that? 15 halves?
What, plus 0?
30, 15, 45.
What, is that plus 0?
Can you explain to him that 5 plus -5 is
No,
0?
I'm talking about that one. It's at 1/2 times 3. That goes to -5 plus 0. Well,
This one?
That's 10. Never mind, that's 10.
So we do
What's
have
that?
to enter it all and like work all out the test. Would this be a calculator?
Did you get 61?
Okay, he didn't say that.
I didn't
He
do
said
it.
that to Jacob.
Yeah, I did.
61. Midpoint Rule.
Oh wait, I got 16.
32 divided by, oh, that's 42. Alright. That's 42 divided by 221, 66. Alright. Example B, midpoint rule, n equals 2. So you're going from 0 to 6 is one subinterval, and 6 to 12 is the next subinterval. So the midpoint is at 3 and 9. So you're going to use the y value that's associated with the midpoints. So that's the height. So the width of the rectangle is 6, so it's 6 times, the height is 5, plus 6 times 10. That gives 90. So that's an answer to B. Sorry. Please let me know if you can't see what I'm writing. Okay, so I'll say it again. The width was 6, the height was 5. The width is 6 again because it's uniform width, and the height was 10. So the midpoint is using the middle number in the interval, in the subinterval. Yes, sir?
So you're always going to use where you draw the line and it comes down right there in the middle. That's always the number you use multiplied by the two bottom numbers.
I did not understand what you said.
So you see how like we use 6? Did we use that because it's right there in the middle, or did we do 3?
I did 6 minus 0 is 6. 12 minus 6 is 6.
You gotta get
It's the width of the subinterval.
Okay.
Alright, C, right sum. So that means you're going to use the, so remember, this is a subinterval. From 0 to 3 is a subinterval. If you're using the right sum, you're going to use the right endpoint of each subinterval. So it's going to be at 5, -5, 10, and 20.
I know.
Okay? And each width is 3, so it's 3 times the sum of those things. So it's 5 plus -5 plus 10 plus 20. That gives me 90. And then D, left sum, this time you're going to use left side. The width is still the same, so it's 3 times 4 plus 5 plus negative 5 plus 10. So what's what? What's that? What's that? What is that? 42? Is that 42?
Yeah.
Only because they're asking the wrong question. Upper sum, so you're looking at each subinterval, and you're looking at which one's the higher one. So in the first one is 5. The widths are still the same, so it's 3 times whatever. So it's 5. And then this subinterval, 5 is the higher one again, so it's 5. And then between negative 5 and 10, 10 is the higher one. And then the last subinterval between 10 and 20, 20 is the higher one. So what's that? 10, 20, 40, 120.
Yep.
Then F, this is the lower sum example. The width is still the same. So between 4 and 5, 4 is the lower one. Between 5 and negative 5 is the lower one. And it's going to be negative 5 again between negative 5 and 10. And now between 10 and 20, 10 is the lower one.
Not sure about that.
So that's going to be 12.
Yeah, that's what I got.
So
That's
it's
a
somewhere
huge
between
gap.
12 and 53.
Yeah, that's crazy. You know what's even crazier? The average is still pretty high, isn't it? 132? Oh, no, it's not. All right.
Oh, because then you get the 66 from 8.
All right. Don't count on that, though. Okay. In example 2, you're given the rate of growth. And in part A, you're asked for the population function. Yeah? Oh, my bad. All right, G, find the average value. So using left sum. So you just use the answer from part D. Part D had left sum. The answer we have is 42. So to answer G, it's same as from 0 to, what is it? 12. Yeah. So we're looking at the interval from 0 to 12. That's what it says here. The interval is from 0 to 12. Average is you're going to divide by the length of the interval, 12. And the approximation we have, is 42. So it's 42 over 12. What is that?
42.
3.5?
Yeah, that's what I got.
All right, so that's G. All right.
Wait, can you a minute?
So basically the average is divided by all the numbers. By the,
Divide by the length of the interval. Can you say that for me?
the length of the interval. I agree. Wait, why'd you want me
That
to
is
say
correct.
That is correct. All right, ready for 2? Number 2, the rate of growth of a certain population. Right, so they give you the rate of growth, and they're looking for the population function. So that means you're going to integrate that.
Wait, watch. You got from 0 to 12. Why wouldn't it be 13?
Because 12 minus 0 is 12.
Yeah, but 0 is still a number.
Yes, but it has no space in 0. Okay, the length is different from how many digits there are.
Okay.
You understand that? Okay, length is different from what you're thinking of. All right. So to determine the population function, and they give you a growth rate, you're going to integrate that and solve for C. So this is going to be integral of 5t cubed plus 200t to the 2/3 dt. And you're going to solve for C when you integrate that. So that's going to be 5/4 t to the 4th plus 200 over 5/3 t to the 5/3. Sorry, I put the 5/3 in a weird spot, usually under this, but it doesn't really matter. I'm going to clean that up some before I solve for C. So that's 3/5 of 200 t to the 5/3 plus c. Clean it up some more. 5 goes in 240 times, so 40 times 3 is 120. Now, so that's my population function. Alright, now I'm going to solve for C. We're told that the initial population, that means when time equals 0, was 800. So we're going to plug in 0 for t and solve for c. So t equals 0 wipes out all that, so we'll just c equals 800. So my population function equation is 5/4 t to the 4th plus 120 t to the 5/3 plus 800. Now, just because it is commonly c equals whatever the initial value is, don't count on that. Right? Don't count on that. It might be something else. All right. Yeah. B, especially if e to the x or natural log is involved. All right. Use the population function to calculate the population of 10 years. So you got the population function. All you're going to do is plug in 10.
Can I get some water?
Yeah. This would be a calculator active question. You will not be expected to do this by hand, but chances are good you will be expected to actually get the answer. So be prepared to get the answer for this. So I'm going to put this in, put this in here, put this in my calculator. But notice I'm going to put the function in there, not that. All right, so 5/4 same as 1.25, so I'm putting that in as 1.25. T to the 4th, I'm using x to the 4th. Why does the 4 not register? All right, plus 120, x to the 5/3, 5 divided by 3, plus 800, plus 800. All right. Now, the best way to use a calculator with a function like this, I'm going to go to the home screen. I want to plug in 10. I'm going to pull up y1 by using alpha. What is that? Trace and press enter. That's y1. This understands functional notation. y1 is the name of the function. I want to substitute 10, so I use parentheses 10. That gives me 18,869. Well, 70. 18,870. 18,870. All right. So that's the predicted population. That was example B. All right. C. So this is the answer to B. C. Find the number of years it takes the population to reach 25,000. So going back to the calculator. Remember, this is a calculator active question. I have the population equation in y1. I put 25,000 in the other one. And then I go to window. So you got to keep in mind. So this is the standard window, -10 to 10. My numbers are in the thousands. And the y values are in the thousands. So you should not leave it like that. So I'm going to leave negative. Actually, I don't even want negative 10,000. I'm going to put 10,000 instead of negative 10. And I want to go as high as 30,000. Okay? And the x values, I'm going to assume, I like to have the x-axis on the screen. And I'm going to put like 15. That's me guessing it's going to be under 15 years. All right. Then I graph it. You think?
Screw the zoom fit.
I think it just takes so long.
No. I think the window's wrong.
Screw the zoom fit.
What did I do for the window?
100,000.
Oh, 100,000. One too many zeros. You guys couldn't tell me. You couldn't hear me say 10,000, then me type 100,000.
What if you do zoom fit?
If you zoom fit, then you win.
What about zoom fit?
Yeah, you can use Zoom Fit.
That's pretty good too. Look.
All right. Now what you're looking for is the intersection. You're looking for the intersection. Alright, so the intersection, you're going to use second calc or second trace. We're looking for the intersect. Look for number 5. And intersect, I prefer intersect because you can just press enter, and then press enter. And it says 10.9167. So 10.917. So T is about 10.917 to reach 25,000 people. Alright. So calculator active question, let the calculator do the work.
Wait, I got like 6.333.
Yeah, you're wrong.
No, but I got.
You got that one right.
That's the answer to some other question.
Yeah, wrong problem.
Yeah. Alright.
So I got it right.
Okay, that was C. This was the answer to C. Now we're looking at D. What is the average population from 0 to 10? So to get the average population, go to the home screen. Alright. So to find the average population, you want the population equation integrated between 0 and 10 and divide by 10. So what I'm going to do is call up my integral, which is alpha, what is that? Window and choice number 4. So my integration comes up. You're going from year 0 to year 10. Did I put 40?
Yeah.
I think so.
I'm still putting 40. Alright. And I want to put in the function. I already put the function in y1, so I'm calling back y1. Press enter. Alright. And the variable is x, so put x. Remember, I'm going to take that answer and divide by the length of the interval, so I'm dividing by 10. Press enter.
Takes forever to load.
This is forever. And I get 5,388 or 389. So D, 5,389. Okay, that's the average population over those 10 years. Alright, during which year does the population equal the average? So now I'm looking for 5,389. Alright, so I'll go to the y equals screen. And I might be able to just put in that answer, huh? Clear. Second answer. Okay, that's not going to be reliable. I'm just going to type it in. 5389. Alright. Okay, now what am I doing? Alright, so I'm doing the same thing before. Someone suggested zoom fit. I'm going to do zoom fit. I believe that's choice 0.
I agree.
Well, I guess that's alright. Alright, so you can see the two functions. The horizontal line is the population 5,389, and obviously the other one's population equation. I'm going for the intersection again. So it is second calc. I'm going for the intersection again, so I'm going for choice number 5. Press enter on that. First curve, enter. Second curve, enter. And then the guess, press enter. And it gives me 6.321. So the answer to E is 6.321. Okay. Is that it?
Yeah.
Yes, there we go. Alright, that's the answer. We're done with number 2. We're now moving on to number 3. Number 3, particle motion. Particles moving along the line. The graph of V of t. So V of t is the velocity of the particle. Is given in that figure here. So this is the velocity graph. Make sure you read it well because it's really hard. Okay. Evaluate the total distance. So total distance, okay, you're given velocity. Total distance traveled. So we're doing 3A. Let me write down the keywords here. Total distance of a moving particle is going to be the integral from 0 to, what is this, 10? Of the absolute value of the velocity. Okay? So if you do absolute value of the velocity, but you're not given an actual function, but just the graph, you're not going to take the negative area, you're going to take that as positive area. So now just find the area, but you want positive versions of it.
So when you find the total distance, is it always absolute value?
Yes.
Okay.
Alright, so that's going to be what? So this, is this area 4?
I got 7.
This area,
Yes,
no,
sir.
just that part.
4, yeah, that's 3.
Is that 3? That looks like it's 3. 3, 2, yeah, 3. And this, what about this trapezoid? What's the area of this trapezoid? Is that 9?
Yes.
Okay. Alright, so 7 plus 9, 16. So then the answer is just 16. Okay? B.
You don't have to do this triangle at the end?
That's after 10.
Oh.
Right? This area is after 10.
Not all of it though.
Not all of it?
It looks like it. Like,
You're reading too much into it, buddy. Just say all of it is.
Alright.
Alright. Example B, find the displacement. Displacement is, okay, so the way I'm going to explain it is, so the particle is moving along a horizontal line. So a particle can move from here, and then it gets to here, and then it comes back, right? That's that negative movement. So the displacement is how far is it from here to here. So if that's the case, you're just going to do 0 to 10, but not absolute value. Okay, 0 to 10, not absolute value. So that means this 7 below the x-axis now has a value of negative 7. So now you're going to do negative 7 plus 9 is 2. So the answer to B is 2.
I agree.
I agree.
Oh, that's 3.
All right,
I can confirm.
thank you. All right, we're moving on to example 4. Okay,
U substitution.
okay. Number 4. This one says, the directions are stupid or mistaken. It says evaluate the following definite integrals, but only one of them is a definite integral. So all you're going to do here is just integrate. This is an indefinite integral. We're going to treat it as such.
Is
All right.
7 the only definite?
7's the only definite integral. All right. So this one requires u substitution. U equals 9 minus 5x squared. So du equals negative 10x dx. I have noticed a lot of you leave off the dx when you do this, and then get lost of what to do with the dx. That's because you're leaving off the dx. Alright, I have an x dx in my problem, so I don't need the negative 10. Since it's only a number, I can move it. So that's going to be negative 1/10 du equals dx. I'm sorry, x dx. So I'm going to replace the x dx with negative 1/10 du. So now I'm doing my substitution. So it's square root of u and negative 1/10 du. Alright, because that's just a number, it can pop out. So it's negative 1/10.
So it's right here where you have the x dx.
Yeah.
Does that get absorbed?
Yeah,
Okay.
okay. Well, x dx gets replaced by du.
Yeah.
It's not absorbing, it's being substituted.
But what if you have a
It's
number-
absorbed when I integrate.
Like what if you have like +2 or something?
Then you have a problem.
And
Then this doesn't work.
okay.
Alright. So now I am moving, now I'm integrating. So the integral, add 1, divide by the new exponent plus c. So that's negative 1/10 times 2/3 u to the 3/2 plus c. So I'm going to clean it up before I replace the u. So that's negative 1/15. I'm going to replace the u with what it originally was. So it's 9 minus 5x squared to the 3/2 plus c. Alright, that's number 4.
So wait, when you do u substitution, it's u, blah blah blah, and then it's du. So the variable is like u is like the variable.
Yes, that's the point. Yes.
That's all it is.
You said
Hey. He has a eureka moment. Don't mock him when he's having that moment. Alright.
Crazy.
Alright, number 5. Number 5. This one is secant squared x square root of tangent x. Now, some students have problems saying what's u, what's not u. What I suggest you do, one, you really need to know your derivatives. If you don't realize that secant squared is a derivative of tangent x, it makes it incredibly difficult to choose what u is. Okay, so you've got to spot those relationships. That the derivative of tangent x is secant squared x dx. So if you don't know your derivatives, u substitution is going to be horrible.
What's the derivative of secant squared x?
Okay, so good question. Question was, what is the derivative of secant squared x? So we'll just take a side note here and find that derivative. So secant squared x, written like that, but it also means this, right? Secant to the second power.
Yeah.
So now you got to use chain rule. So it'll be 2 times secant x. Because I took the derivative of the outside. Now take the derivative of the inside. The derivative of the inside is secant x tangent x. So that means that's 2 secant squared x tangent x. Okay? Alright. Now, so secant squared x dx, it's right here in the problem. So I can replace it with du. So du over square root of u. I'm replacing the tangent x with u. Alright, let's clean it up a little bit. I'm going to write that as u to the negative 1/2 du. And then use power rule. So it's u to the positive half over 1/2
Wait,
plus c.
I think you have u and du mixed up on the top right.
He's good.
U.
He's good because tangent was u.
So the derivative of tangent is secant squared.
Alright, so 1/2 is square root. So I'm going to write square root and tangent x plus c.
Well, we can't. Do we need to leave it? Well, can we leave it with 1/2? Or do we need to take it back now?
Okay, the question is, did I have to rewrite the 1/2 in the square root? So probably this problem will be a multiple choice question. The question is, will you recognize what's on the paper? Okay, so you just go by what your choices are. Chances are good though that they're not going to leave a 1/2 as a square root. I'm sorry, they're not going to leave a 1/2. They're going to change it to a square root. If it's a 3/2, they're probably going to leave a 3/2.
Yeah.
Number 6. That's the integral of x secant squared x squared dx.
Oh yeah, what is it?
Alright, so here I know that secant squared is the derivative of tangent x, which is nowhere to be found. However, if I integrate secant squared, that's tan, because secant squared is a derivative of tangent x. So I'm going to let u equal to x squared. That's the only thing that's bothering me. So du equals 2x dx. So I have an x and a dx. I just have an extra 2.
Bring it over.
Bring it over. So it's 1/2 du equals x dx. So I continue with my substitution. So that's going to be secant squared u, and x dx is replaced with 1/2 du.
And you said it's fine if we just go ahead and bring the 1/2 outside of it.
Yes,
All right.
beautiful.
'Cause I always get thrown off whenever I try to put it in.
Okay. All right. The integral of secant squared is tangent. Then go ahead and replace the u with the x squared. What's up? Yeah.
I know it's a U substitution problem, but do we have to work it all the way out before we plug it back in, or can we plug it in when we feel comfortable with plugging it in?
I don't know how to respond to that.
Like,
Here's the thing. This U substitution idea is to change it into something that you recognize. If you recognize it at the beginning, you don't even need to change the U at all. Like, remember the first time I did this, I made no changes. I did pattern recognition, which is the form of U substitution. So, in terms of changing back and forth, that's completely up to you. Okay? Just be careful of changing it to U and then changing it back to X before you integrate. That will be the only thing I'd be concerned about. But it doesn't really matter. Doesn't really matter. Alright, 7 is the only one that's a definite integral.
With definite integrals, do you have to graph it?
Okay. Alright, so his question is, we have a question on the floor, Zion. Alright. Do I have to graph this? The answer is no. Okay? If you know how to integrate absolute value, then there's no need to graph it. Do you know how to graph? Do you know how to integrate absolute value?
I do now because I graphed it.
Okay, alright. So here's huh?
X plus 3, X plus 1.
X plus who?
X plus 1.
Why X plus 1?
On 7. On the function.
No.
Oh, that's what you mean. I copied it wrong. Alright. Okay, thank you. Alright, so there is a way to do this without graphing it. I'm going to show you that, and then I'm going to graph it, okay?
Should we do it the graphing way or non-graphing?
I think graphing is easier. I think graphing is easier.
Is there going to be a non-graphing part of this?
There's a what?
Non-graphing part?
Yeah.
Is it going to be a lot?
It's going to be about 50-50. Between the definite integrals, there'll be half of them where you have to graph it, or a graph is given, and the other half where you just do it by hand. Alright, so this one is the one I would do by graphing. But generally speaking, if you were to graph it, the graph is already provided for you. Like, you don't have to graph it yourself. Okay? But this one's easier by graphing it. So the graph of the absolute value of x plus 1 looks like this, where it hits at -1. This is -3. This is +3. I find it disturbing that you guys, so how do I know how tall it is? It's the graph of x plus 1, absolute x plus 1. Plug in -3, so the height is 2 here and 4 over here. Right?
Yeah, that's
So this is 2 by 2, so that's 2. This is 4 by 4, so what's that, 8?
Yeah.
Alright, so then that's equal to 10.
Wait. Why
Yeah.
are you plugging -3, not 3?
So that's just the answer?
I did plug in 3.
That's
The answer
plugging
just 10
-3.
then?
I did plug in -3.
Wait, how'd you get
I plugged in both of them.
Wait.
But then,
It's not.
You go
so you got 4, and then you got what?
It's not
-2?
2.
4 minus 2.
What are you talking about?
You get 4 minus 2, you get 2. After you
4
plug in
minus
both of
2, you get 2. What do you mean 4 minus 2?
Because you plug in 3, you get 4. And then if you plug in -3, you get
2.
2.
So it's
So the height is 2, height is 4. This width is 2. 2 times 2 is 4. Divided by 2 is 2. This is 4 by 4. 4 times 4 is 16. Divided by 2 is 8.
Yeah.
So the height is 2 at -3?
Yes. Because I plugged in -3 into absolute value of x plus 1. Right? -3 plus 1 is -2. Absolute value of -2 is +2. Don't forget to take the absolute value after you calculate the
Yeah,
inside.
if you plug in 3,
That's okay. 3 plus 1 is 4. Absolute value of
like if you think that it's absolute value, so you plug in -3 as 3.
then it's messed up, right?
Exactly.
Alright. Anybody want to see me do this without graphing it?
Yes.
Alright. So I know that x plus 1, hold on. X plus 1 can be written as a piecewise function as negative of x plus 1 when x is less than -1,
Never mind.
and x plus 1 when x is greater than or equal to -1.
Okay, can we just not?
You explain this to me one time, but I don't really understand.
Well, absolute value, you take the opposite of what's inside when
It's negative.
it's negative,
Or like,
right? But you keep what's inside when it's positive. So what's inside is negative when x is less than -1. Yeah. No, you cannot. You have to break it at the -1. Now, so because of that, then you're going to do -3 to -1 of the opposite of x plus 1 plus -1 to +3 of x plus 1.
So why do you have to do that top one? Why can't you just go straight into that?
Why didn't I go straight into this?
Yeah.
Because then, if I went straight there, you're going to say, why is that one negative? Why is that one positive?
Oh, true.
Okay? And why did you choose -1? So all that explains that. Why did I choose -1 and why is it negative?
That's where X is.
Yeah. Alright. So integrate this. That's -1/2 x squared minus x taken from -3 to -1 plus x 1/2 x squared plus x from -1 to 3. Plug in these values. Can I stop?
Yeah.
Yeah.
Do you understand this was a lot more work?
Yes.
Yeah.
Okay.
Yeah.
If you can graph it, I would graph it. Like, if I were asked to do this, what is the integral from 0 to 5 of 2? That's easier to just graph it. Or let's say 10 to 15 rather. That's easier to just graph it, right? Start at 10 to 15. It's a height of 2. 2 times 5 is 10. That's 10. Right? Graphing is easier sometimes. All right. Number 8. Okay, this one is using the second fundamental theorem of calculus. So it's d dx of an integral.
You just replace everything with X, right? All the T's with X.
Yeah.
Why are you integrate though, right?
Okay, alright, so here's what you do. You have to realize that taking the derivative of an integral, they basically cancel each other out. So all I'm going to do is rewrite the inside with that variable x times the derivative of x, which is 1. So that's the answer.
Should you change e to x?
Say what?
Should you change the variable to x?
I did.
E?
Because
Wait, so
but
why
e's not the variable, right?
DX.
That t was the variable.
So all you do is just change the x. Like, when would you need to do something else?
Number 9.
Hang on.
How do we find out what DX is?
Huh?
How do we find out what DX is?
What do you mean, how do you find out?
Why is there a 1 on the outside?
It's the derivative of x.
Okay.
So,
So it's the derivative.
So when there's like a 2x up there, that's what
Okay, you talk about when do we find out what dx is?
No, like, how do we get the 1?
Oh, what's the derivative of that top function?
Got it.
Derivative of x is 1. Yeah.
so wait, why is the x at the top of the f big X?
Huh?
Why is there an x on the top of the big X?
Yes.
It's the
Why
problem.
is the x on top?
But why is x?
It's the problem. They could give us a problem like this. 4 up there and x down there.
Yeah, what?
Then you have to swap it. Don't you?
Okay, now it's a different problem.
What do we do?
It just makes it negative, right?
It makes it negative because you have to have the variable up top.
So you have to have the x at the top.
You have to have the x at the top.
Oh, like on the next one.
So why do you have to leave the 1 outside?
You don't. That was written for emphasis.
Yeah, why? Yeah. What is that?
That's the derivative of x. Okay, final answer is just e to the 3x minus 2x. You don't have to leave the 1.
Yeah, that's
I'm just assuming that you don't need me to tell you how to multiply by 1.
Well, I was one way to put it.
And I explained that, right? It's a derivative of x. Alright, number 9. Stop it. Alright, now I'm doing number 9. It's 6 to 3x squared.
Do you start by doing the same thing?
Yes, I believe so, if I understand you correctly. Alright, so I'm going to plug in the 3x squared. So it's 3x squared minus 4 times, because it's the derivative of an integral,
So it's 6x.
6x. You go ahead.
T squared.
T squared?
Yeah. That's tricky.
So that's it.
Oh, variables x.
Alright, so all that becomes is 6 times 3 is 18. X cubed over 9x to the 4 minus 4.
Whenever you do, there's the 6, never mind. But there's the exponent right here, 3x squared, and then to the second power. Like, can you tell me how you did that?
The 9x to the 4? Or the 18x cubed?
So you can just add them two right there.
Can you be more specific?
You can add the 3x squared, you can add that squared and the square on the outside of parentheses.
Yeah.
and then you do it to the fold.
Yeah.
Alright.
Right. 3 squared is 9. X squared squared is 2 times 2 is 4.
I'm
not adding.
Multiply.
They lost a lot.
Say what?
Could have lost some.
Ready for 10?
It's like a bunch of hoodlums.
Oh man.
One thing I don't like about this assignment is there are no tables where it's non-uniform width. You need to be prepared to do a table where they're not the same width.
Can we do one?
Yeah, we'll do one before the test.
Sweat too.
Yeah,
Does that mean the only thing that's really going to change up is just a subtraction? Like it's not going to be the same number every time.
Correct.
Like the majority of the rules.
correct. All right, so number 10. Number 10. Number 10.
Wait, Sweat too.
Yeah.
If it's not like uniform, like can we just like make it like to where it's like all the same like distance? Can we do that or no?
That won't work. Alright. Estimate the area of the lot using trapezoid rule when n equals 6. So you can just do 1/2 the height, but all of them are 50, right?
Yeah.
50. So then all you gotta do is just add these things. So it's 450 plus 362. That's the first pair. And then second pair would be 362 again, plus 305. And then 305 plus 268 plus 268 plus 245 plus 245 plus 156 plus 156 plus 0. If numbers are like this, it's a calculator question. So I'm using the calculator. I mean, I can have numbers like this on a test where it's non-calculator. However,
It's pretty big.
it would be like less numbers, like maybe only 3 of them or something. Did you guys get 71,175?
Yeah. Wait, what? I got 78,600.
Sounds good to me.
78,050.
Ah, silly guy. Let me try it again. 450 times 362 times 2 plus 305 times 2 plus 2 times 2. Is that a new dance, Kaylee?
This is the most detailed concept in it.
I was
An hour later.
kind of.
Yeah.
Yeah.
We
I
ended
saw
up-
Emma.
Oh yeah, she told me she saw.
Holy cow.
We ended up going.
I'm so screwed for this. Ended up going through.
Oh, I got an even bigger answer. You got 78,050?
I'm doing pretty good.
Is that what you got?
Yeah.
Okay. Not sure what I did wrong the first time. Okay, that's the answer to A, 10A, 10B. Midpoint rule. So n equals 3. So that's 1, 2, 3. The midpoints are there, there, and there. The widths are 100. So it's 100 times 362 plus 100 times
You
268
slide it up into her.
plus 100 times 156.
What, did you do like 100 the big parentheses?
Yeah. In fact, that's how I'm putting it in the calculator. And I got 78,600.
Yep.
I'd say the trapezoid rule is more accurate.
I agree. If you're given a multiple choice test and they give you a graph they give you nothing else, and they say integrate, then trapezoid rule is your friend. Use the trapezoid rule.
What? But will that take an estimation?
It will be an estimation. You can't help it. If they don't give you anything else, it'll have to be an estimation. And the thing is, it won't even be straight like this. It'll be a curve. It'll be a curve like this, and they'll give you nothing to work with.
I mean, that's just.
So you have to, no, that's why the trapezoid rule is available.
Wait, so you would use trapezoid rule with that?
Yeah.
You wouldn't use upper and lower?
I would not.
Wow, that'd take too long.
No, it's not a matter of time. Trapezoid rule is the most reliable one.
So just do, well, how would you do trapezoid rule? 1/2 times,
Right, you have the two bases and whatever the width is. I would keep the same width for all of them.
wait. Oh, so you split it up.
Yeah. No matter what you do, you have to split it up.
How do you know you split it up where you split it up?
You split it up where it's easy to split up, like every 1 unit or something.
That way you just have like,
Yeah, easy.
so you just have 1/2 times the height
Yeah.
times the one. But what about when you have one height on this side? Well, I mean, it just goes to the highest height, right?
Well, it goes to the height. You should not have more than one height for each x.
Well, I mean, like when it goes up like this.
Right, so you use left height, right height, remember? Those are the bases. Those aren't heights. The height is the width of the trapezoid.
My plan.
Is the width of the
I'm just
subinterval.
gonna.
Okay, stopping the video here.
I'm gonna have to